So today we're going to talk about data. And where we are is that you know how to train a model given data. Last time we saw evaluation, so we know what a good model is. And for the next two lectures, this week we're going to focus on what data should we train on. And I want to argue that data is the most important thing to get right in language models. And one justification for this is if you look at what companies actually disclose. So here is the Llama 3 paper. They have full transparency into the architecture. Well, of course, because it's open weight model. They even tell you about their training procedures, but they don't say anything about their data. So they just say, we train from a variety of data sources and do some stuff. And there's good reasons for this secrecy. One is that data is kind of your competitive secret sauce, competitive dynamics. You don't want to let your competitor knows what you're doing. And the second thing, which we'll talk a little bit more about, is copyright liability. You don't want to get sued if you tell people you're training on certain types of data. So data is a long topic in machine learning. And before foundation models, data work meant you annotate label data for supervised learning. Nowadays, there's less manual annotation, at least in pre-training, but there's still a lot of curation and cleaning work that needs to be done. And so fundamentally, this hasn't really changed. Data has always been a bottleneck and always will be a bottleneck because it's in some sense a long tail problem and that scales with human effort. So if you have a lot of people trying to work on a problem, well, there's only so many people that can work on architectures and systems, but data, well, that's like, especially if you're training a foundation model that's trying to do all these things, you can paralyze that effort easily. So that's why these data teams and these model developers are actually quite big. So data comes in at different stages of the pipeline. Today we're focusing mostly on pre-training. So pre-training, you take raw data, these are documents from the web. Then you move into mid-training where you train on more high-quality data to enhance certain capabilities and give long context, things like that. And then finally post-training where you're training on things like chat transcripts or if you're doing reinforcement learning, you get some environments that you're training on. This becomes more task specific. In practice, the lines are a bit blurry. And there could be more than 3 stages, but this is sort of a basic template. The trend is that we go from training on large amounts of low quality data to smaller amounts of high quality data. So as a result of this process, you'll see in the literature, people talk about the base model. This usually means after pre-training and mid-training. Instruct models or chat models are after post-training. But of course, the lines are becoming blurry enough that what is a base model anymore is really kind of unclear. And more recently, the largest models are, there's no base model. There's just Quen 3.5, 397B, and that's it. You don't see the intermediate checkpoints. So for models that are open source, like OMO from AI2, you can see everything that's happening. And so we'll study some of these models. So for example, in pre-training, there's a bunch of sources which we'll talk about what these mean, but some web pages, academic papers, math pages, proofs, and so on. There's mid-training, higher quality web data, instruction data, a bunch of synthetic data often goes here. And then finally, post-training, there is a bunch of chat logs. There's more math and reasoning and coding and you do safety at this point as well. So, what are all these data sets? How do you choose them and how do you process them? So that's the main question. Okay, so in the spirit of the class, we're going to talk about data. I'm going to go start from scratch. So where does data come from? Okay, so one might hear in the hallway, oh, language models are trained on the entire internet. So first of all, this doesn't really quite type check because for that to be true, it would have to be an agent that, like an RO agent that goes on the internet and like does stuff. But that's not actually how pre-training works. Slightly more accurately, it's trained on the public World Wide Web. But this is not quite accurate for reasons I'll explain. Okay, so first of all, the web is actually a bunch of live servers that just exist in the world and you can connect to. So take any website, you can go and download the page. You can basically send a request and get back a response. So you can't actually train on these live servers unless you're training an RO agent. So typically what you do is you have a crawler, or someone builds a crawler, not necessarily you. The crawler needs to discover what web pages are out there, starting with a seed set, and it downloads this discovered web pages as it's crawling. So, but now, still you can't just run a crawl and download all the web pages on the internet. And there's a few reasons for this. One is that a lot of the web content is actually dynamic. So especially these days, a lot of sites are apps. The URL isn't even a full specification of the content. It's just an app that you interact with. And you need to often click buttons or submit forms to access content. For example, if you're on Discord or something, it's not like you can just like curl Discord and get all the content on Discord. Okay, so that's one kind of thing, and a lot of content is actually known as kind of in the deep web, which is not just like you're doing web page crawling and following hyperlinks, which is a very kind of traditional model of web crawling. The second thing is that authentication. So some pages need a login and account, and generally you have to pay. For example, the Facebook, X, LinkedIn, New York Times. There's actually huge amounts of content that are actually locked up behind these walled gardens. So these are technically on the internet or on the web, but you can't just build a crawler and go crawl Facebook. I guess if you're Facebook, you can crawl, well, you don't need to crawl Facebook. You have the data and you can train a model. Or if you're XAI, you can train on X. But if you're anyone else, you can't actually access this content. So, okay, suppose you don't have the authentication issue. There's still potential restrictions here. So there's something called robots.txt. And this is a file that is usually placed at the root level of a directory such as nytimes.com, and it basically tells you what you're allowed to crawl and what not. So a lot of things are disallowed, such as OAI search bot or perplexity bot, Corabot. I think basically ChatGPT user, Claude bot, and all these things. Okay, so this is not a legal restriction. This is just like you're supposed to be a good citizen and look at robots.txt, and if your name is on that list, then you should not crawl. That's basically not even a contract. That is the thing that you're supposed to do. A lot of websites now use something like Cloudflare to detect and block bot activity. So sometimes you've gone to a website and it gives you a CAPTCHA, right? That's because it's somehow some algorithm has detected that you might be a bot, and then it's making sure you're human. And if you're actually a bot, then, well, you can't, you could try to get around this, but generally this is an obstacle in your way. A website might block certain IP addresses or countries, and they might have rate limits. So there's technical restrictions on what you can actually crawl. And then there's also legal restrictions. So websites have terms of service that say if you go to a website, you have to obey this contract to use the website. And the terms of service often will say, if you're a bot, go away. You cannot use the content of the site for AI training or whatever it might be. And also, even if terms of service don't say anything, the content of the website might have, a license, or you might not have a license to train. And we'll talk more about this in a bit. So there's legal restrictions on what you are allowed to train on. these things are also evolving over time. So there's a nice paper by Shane Lamprey called Consent in Crisis. And what they did is they examined the restrictions, both the technical restrictions, robots.txt, and the legal restriction, the term of service, for various URLs in common data sets, which we'll talk about later. And the conclusion was that the restrictions have increased over time. So here's a graphic that shows, the top one shows robots.txt. And if you just look at this red, that's the full restrictions. And up until 2023, everything was fairly constant. And then up until mid-2023, all of a sudden you see the amount of the fraction of websites that have full restrictions on it has grown to almost like 50% here. And for terms, there's a similar trend where I guess in 2016, no one really put any terms on their pages, and now most pages put some terms, and most of the terms say you can't use this for AI. Okay, so even though it was possible to crawl the internet back in, let's say 2020, the internet actually, at least what you can legally crawl, is actually much smaller. So, of course, these are guidelines, and sometimes, either intentionally or not intentionally, you could violate these things. So this is, sometimes you get into these situations where there's this guy who, what was this, I forget the name of this site, was complaining about Anthropic crawling them, hitting their servers 1 million times in 24 hours, which was not good. And then Read the Docs was also getting hammered. So there's a period where, which I think probably has hopefully been corrected by now, that crawlers were hammering websites. And there, here this is kind of interesting, is like even before talking about copyright issues, there's I think problems with crawling because either violating terms of service or robots.txt or just low up down generating a lot of server load, which this costs money for the person hosting it and also degrades service for everyone else trying to use it. So there are issues with crawling, and then of course there's copyright, which we'll talk about soon. That's a whole nother complex can of worms. Okay, and then finally there's these things called shadow libraries, which are also part of the web. So examples are libgen or Anna's archive, and these completely disregard copyright and bypass paywalls. So someone has collected a ton of data, usually books and articles that are all copyright and people have to pay for these, and have made them available for free. And there have been a lot of takedown orders, lawsuits, and these are blocked, but usually these are circumvented because they just make servers in other countries. And the people doing this argue that this is making free what's freely available, what should have been freed, but generally from a legal perspective, this is piracy and copyright infringement. And we'll come back to this point later. So there are a lot of books and papers on this, on these shadow libraries. Okay, so summary so far: the internet is a huge and messy and scary place, and you can't actually get all of it. There are technical restrictions. There's legal restrictions on what data one can access. So now, next time someone says, I trained on the internet, you can tell them all of these things you learned. Okay, so now let's go to the second part of what data can we use. And this has to do with copyright. So suppose you were able to obey the terms of service and you are really a good citizen and you obey the rate limits. Now, there's still a question of, are you allowed to train on this data? And this is an ongoing question that has not been fully resolved, but there has been a bunch of developments in the last year. So the legal context for thinking about this question falls into intellectual property law. And this is a system that is trying to incentivize the creation of intellectual goods. So I think it's remember the spirit of the law is to not just say, technically say no to everything, but to incentivize the creation of intellectual goods. And there's many forms of intellectual property that are covered. There's copyrights, patents, trademarks and secrets. Trademarks and trade secrets. The thing that is most relevant for language model data is copyright law. So copyright law has a fairly long history going back to the 1700s in England. And so 1709 was the first time that governments and courts started actually regulating copyright for this goal of incentivizing innovation and creation. And in the US, more recently, the Copyright Act of 1976 is what I think defines a lot of kind of modern copyright. So copyright protection applies to original works of authorship fixed in any tangible medium of expression, yada, yada, yada. Okay? So a few notes. So not everything is copyrightable. In particular, collections are not copyrightable. So for example, if you have a telephone directory, unless there is some creativity in how you arrange things, this is not really copyrightable. And furthermore, copyright applies to an expression, not the idea. So you can't copyright an idea, like you can't copyright the quicksort algorithm. You can copyright the implementation of a quicksort algorithm, but not the quicksort algorithm. So one thing that happened in 1976 is that the barrier to getting a copyright was relaxed a lot. So more things are copyright. So it used to be that you had to publish something to have something copyright. Now things just have to be fixed. And what that means is that registration of any sort is not required for copyright protection. This is in contrast to patents. Patents, you have to go pay a lot of money to get a patent and in order to file a patent. But the threshold for copyright is very low. For example, you put something on your website. It's copyrighted. That's it. Now, if you want to sue someone, you have to go get it registered, but it only costs $65, so which is much smaller than the lawyer fees that you'll probably pay. So it's really still a very low bar. So one thing to know about copyright is that it lasts 75 years. And then the copyright expires, and whatever that content gets released into the public domain, and this is now permissible. Everyone can use it freely. Okay, so a lot of people who have lived in the past, all their great works are in the public domain, which is great for everyone. So the rationale here is that you're incentivizing innovation. So when an artist or a creator creates something, you want to protect you don't want someone else to just take it, so you protect them for a while, but after 75 years, presumably it's not worth protecting or they're passed away or something, so it doesn't make sense to keep things copyrighted anymore. Okay, so basically everything on the internet is copyrighted. Okay, so you're saying, wait a minute. So that means is everything, if I train on anything, that's a copyright violation? Well, not necessarily. So everything is copyrighted, but you can use copyrighted works. And the way you do it is, A, you either get a license for it, or B, you appeal to the fair use clause. Okay, so a license is, from contract law, is something that a licensor grants to a licensee. It basically says, don't sue me. Like you can use this work in the ways that the license permits. So there's a really nice license called Creative Commons, which allows something to kind of act like it was in the public domain. Enables free distribution of copyrighted work. So examples, include like Wikipedia, OpenCourseWare, Khan Academy, all these things. It was created in 2001 to essentially bridge public domain and existing copyright, because otherwise you have to wait 75 years. But what if the creator says, I actually want people to use it? They can now have a legal means of saying, I put a Creative Commons license on it. It's going to act like it's in the public domain, and and everyone can use it. So far, things in the public domain and things that have Creative Commons licenses are permissive. You can use it. But there's many other things that times where you don't have, it's not a Creative Commons license, it's not in the public domain, you have to get a license. So if you have money, you can pay someone to give you a license. So there's a bunch of deals between model developers and content, platforms that allow the model developers to license the data for training foundation models. Okay, so that's the first thing. You can get a license, either Creative Commons or you can pay someone for a license. Now, if you don't want to pay, you can appeal to fair use, which is a more complicated matter. So this is Section 107 of the Copyright Act. And there are basically, fair use says, I can use this anyway, even if I don't have a license. And there's 4 factors to determine whether fair use applies. So the first one is the purpose or character of the use, like what are you trying to do with it? And none of these are hard rules. They're just tendencies which have to be weighed in court if it comes to that. So for example, if you're trying to do something for education, it is more likely to be fair use than if you're trying to sell and make money off of it. If you transform something, then that's going to be more favor than if you just literally host the identical copy. The nature of the actual copyrighted work is also important. So things that are more factual are more likely to be fair use than fictional works, right? Because if you write a summary of World War, a page about facts about World War II is less. There's less protection over my really creative poem. And then the amount of portion of the original work, so using a snippet, is favored over the whole work. So if you just take a little bit, that's not as bad as taking everything. So that's fairly straightforward. And the final thing is kind of related to original motivation. It was like, why copyright at all? Is to protect and align economic incentives. So the effect that what the use has on the market for the original work. So if you take author's work and you provide an alternative and that decreases the amount that the original author could monetize their work, that is seen as potentially bad. But if you're transforming it in a way and adding, going to a new market or doing something else with it, then that's going to be treated more favorably. Okay, so here's some examples of fair use. You can watch a movie and write a summary of it. You can re-implement an idea, like an algorithm, not copy the code. And then there was this famous lawsuit between Authors Guild and Google. So if you go to Google Books, you can see snippets of various books, which are copyrighted. So there was a huge deal about whether this was deemed fair use, because you're sort of redistributing other copyrighted work, and eventually meaning after 11 years, this lawsuit was settled in favor of Google, which is why this thing exists. And this has set some precedent for thinking about whether language model training is fair use. One thing to note is that copyright is not about verbatim memorization. So this might be, I think, for an ML audience, this might be a little bit new because a lot of papers are focused on verbatim memorization, but that's one way you can violate copyright, but not the only one. So for example, plots and characters can be copyrightable. So you can copyright Harry Potter, the character, not any particular book or anything. But there are some exceptions. For example, if you're parodying something, and so you're creating something that looks like a derivative, but as long as you're making fun of it, it's actually more likely to be fair use. So yeah. So a lot of copyright is about semantics. It's definitely not about n-gram overlap, and also about the economics. Okay, so what is the implication for language models? So first off, copying data, like even if you're not training, like even the mere fact of copying, which is in the word copyright, is potentially a violation already, even if you don't do anything with it. Okay. Training a model, I guess this is not really let's see, how do I take this? This is not necessarily a fact, but is intuitively has a transformative flavor, right? Because it's certainly not, it certainly seems different than just like rehosting another work, right? It's doing something transformative. And in some sense, the models are really trained on this data as a means to the end. You were trying to extract the general idea, learn about the world and how it works, rather than only just the concrete expression. And the other thing is that regardless of copyright, language models can definitely affect the market. So I think this is also, remember, that's the fourth item for fair use. So by negatively affecting the market, you are more likely to be ruled not fair use. Okay, so fair use is kind of a little bit slippery. Suppose you have fair use or you have a license. Remember that there's still terms of service that prevent you from actually just getting a piece of work. For example, YouTube has all these videos which are licensed, but the terms of service prohibits just downloading the videos using a bot, or like scraping, right? So which is another layer. So there's multiple layers of restrictions here. Okay, so let me talk a little bit about where things are on the legal landscape. So back in 2023, New York Times filed suit against OpenAI saying, you train on our news articles, and look, here's evidence we were able to actually prompt ChatGPT to generate a news article almost verbatim. I don't think this is still pending. There's a case against Anthropic where the allegation was you pirated millions of books and you train on these books to make Claude. Just last year, this was a kind of a landmark ruling that said, actually, this particular instance of training is fair use. However, Anthropic, you're still in trouble because you pirated all these books, and that is a no-no, right? So notice that this has nothing to do with training, just a mere fact of pirating. I mean, which is this is not a new thing, is illegal. Anthropic actually, interestingly, had bought and scanned all the books, which is actually fair use. So the court said you're allowed to scan, you buy a bunch of books, rip off the binding, scan it and digitize it for your own use. That's fair use. But that doesn't absolve you of your sin of pirating. So you can't pirate and then buy it and say like, actually, never mind what I just did first. So the outcome is that Anthropic paid $1.5 billion to settle the author. So this is like about $3,000 a book. So there's also a lawsuit against Meta. The allegation was that you trained on our books. And this was, as we'll see later, actually revealed in the Llama paper. And the judgment, which came right after Anthropic, was yes, training is fair use. And then they also torrented some books, so that's still pending. So that's probably, if precedent holds, this is also not going to be good for Meta. Okay, so the summary so far is training, so to speak, has been deemed fair use, or at least it has been not deemed not fair use. The new rulings have so far been narrow. It's not to say that any training on any copyrighted content is fair use, but in these cases, it's fine. Pirating books is clearly illegal. I guess we already knew that, but this is still a very active and evolving area. Okay, any questions about the sources of data? I think before we get into the actual data sets, I just want to kind of set the stage with this kind of a more general social context. Yeah. The question is, what do I think of voice data in 11 labs? I don't know too much about that, so we can talk offline. Yeah.
Am I allowed to kind of, initially it's Creative Commons, but can I update my license later on to sort of block certain usage? And so, like, what is the role of time play in this? Like, can I then train on like older version with like a more permissive license if the creator copied it to like a more restricted license?
Yeah, so the question is, what happens with time? If you have one license and then it gets changed, what happens? So first, I'm not a lawyer. But second, so the first license, I believe you're still allowed to train on it, but what happens is that the license usually applies to not just, let's say, a fixed set of documents. For example, Reddit, there's constantly new content being created, and the license being changed means that you wouldn't be able to train on the later things. Okay, so let's look at various sources of data. So let's go back to crawling. So most model developers have their own crawler because they want to have full control over what the data is. Fortunately for the rest of us, if you don't want to build your own crawler, there's something called Common Crawl, which has been around for quite some time, since 2007. And every month they run a web crawl, gets about 3 to 5 billion web pages. Each crawl has some overlap with a previous crawl, but they try to diversify and get new pages. So there's 300 billion pages so far, which seems, this was from their website. It seems a little bit big because if you multiply this number by 20, you don't quite get 300 billion, but that's what they say. So how many URLs are out there? That's really hard to estimate. So the Google search index is at least 100 petabytes according to them. And each Common Crawl dump has about 2 billion web pages, so that's about 372 terabytes. And this is not including images. This is just mostly focused on the text. So crawling is conceptually straightforward, but all the gory details are in the implementation. You start with a bunch of URLs, and then you iterate. It's basically graph traversal. You pop a URL from a queue, you download it, and then you look at all the hyperlinks in that page, and then you add them to the queue. And generally, this is done in parallel over many machines. There's many decisions here, which pages to download. You have to respect robots.txt. Don't overload the server. Sometimes the websites change, and so you want a policy that will download, frequently change pages, but not spend time downloading pages that don't change. So there's some policy around that. And like I mentioned before, URLs are dynamic, so both sometimes the same URL leads to different content depending on like some state of the browser, but also many URLs might lead to the same content, so there's a lot of duplication that happens if you're not careful. In particular, mirror sites explicitly is about duplication. So Common Crawl releases their dumps in two formats. One is a work file. So this is the raw HTTP response. Right? So this, remember, HTTP protocol is that you send a get, here's a URL, and then out comes a HTTP kind of response, and it's just the work file is that response. They also do some processing. They convert to a wet file, which is necessarily a lossy process. It turns out that this is not necessarily the best way to use the web. The HTML to text, there's many tools for this, including Traflatura and Brasilia parse, and the way you convert actually does matter. So this is from the DataComp LM paper, which we'll talk a little bit about. They did this ablation where you look at the web files that Common Crawl releases versus these other tools, and it seems like Traflatura and Brasilia parse are better. Okay, so one thing you can do is just rely on general web crawls. But often, the web is not a uniform place. It's not like there's a bunch of websites and you just get some random fraction of them and that's your data set. There are specific pockets of really interesting high-quality content, and I'll talk about three of those: Wikipedia, GitHub, and Archive. So Wikipedia, all of you know about. It's been around since 2001, and now there's 67 million articles around all these different languages. And Wikipedia is not all content by any means. You can't have original thought in it, because everything has to be kind of referenced and cited. So in some sense, you could argue that Wikipedia doesn't contain anything because that's not already on the web. Well, actually, that's not true, because they can also cite books, which are, obviously you can't easily get them. So Wikipedia is so good. And also there's articles based on notability. So not everything, not everyone can get a Wikipedia article about them. So anyone on the internet can write this content. This was the radical thing about wikis, and it's sort of still a miracle, I think, to me, that this actually works. It just happens that any vandalism gets reverted by administrators or bots, I guess, these days. There's a small number of Wikipedians, like as any sort of peer production system, there's a small set of people who do most of the work. And for example, this guy has like 5 million edits. And one thing about Wikipedia is that every few weeks they do a periodic dump. So basically take all of Wikipedia, packaged into a nice tar file, and then you can just download that. So this is important because you don't need to crawl Wikipedia. In fact, they don't want you to crawl Wikipedia. They just want you to download this if you're going to crawl. And this is much better than crawling. One kind of just a fun aside, or good to know, is that there's this paper that says you can actually poison Wikipedia. So you might think that this vandalism gets reverted. So if attacker tries to do something fishy, you'll just get it rolled back. But what Carlini realized is that these periodic dumps happen at a regular cadence. And so what you can do is you can go in and you can just edit it right before the dump happens, and then the dump happens, and then the edits get rolled back, but the dump still has the malicious content. And if you're able to inject things into web pages, that means you can there's works that show that you can cause the model to, let's say, ascribe negative sentiment to any sort of trigger phrase, like the iPhone. So one takeaway here is that if you consider adversaries, even so-called high-quality contents might contain bad things in them. I think this has been fixed since then. Okay, so GitHub is a good place for code, and code is important not just for if you want coding abilities for your language model, but if you want general reasoning. So GitHub, all of you know, again, it's a live service for hosting code repositories. Been around since 2008, about the same age as Common Crawl. It has 420 million repositories, 28 million are public. Each repository contains, it's not a file, it's, as you know, it's a directory with commit history, issues, pull requests, and comments. Code has generally a lot of duplicates, and this is because either copying code or forking code. GitHub has deemed it you're allowed to train on any public repository with a permissive license. So MIT or Apache licenses are fine. Remember there's two types of data when you talk about GitHub. There's like the repository data, which you can just go and download through the Git protocol. And again, you shouldn't scrape GitHub. You should just download the repository. And then the metadata associated with each repository, issues and pull requests and so on. These are made actually via the GitHub archive, which gives you hourly snapshots of this event stream, which I think is really interesting data. It's basically every single comment or star or action on GitHub gets recorded. There's this Software Heritage Foundation that is focused on the repository, not the metadata, and they aggregate GitHub. GitHub is not the only place where code shows up. There's also smaller entities like GitLab, Bitbucket, and so on, and they aggregate all those repositories. Okay, so Archive, just very briefly, everyone knows Archive. This has been around as a site that allows people to share papers since 1991. Started with physics and now has a lot of other areas in it. Each of the 3 million submissions has the metadata, a PDF, and optional LaTeX source. Okay, so already you should be thinking, well, what does it mean to train on Archive? It's not clear because this is, well, you have to convert the PDF into a text, or you can use the LaTeX source, which is a bunch of files. It's not peer-reviewed, but there is some approval process, and authors can choose to maintain the rights or put in the Creative Commons, which so everything is actually very clearly licensed. All the metadata is under permissive license, so you can use that regardless. And then you can go and you look at all the papers that are Creative Commons licensed. You download those and you can use them. And I think most archive papers are Creative Commons. And then again, this is available. You don't crawl archive. You just go down to bulk download it from some website. Okay. So any questions about sources of data? Yeah. Are there restrictions on data
generated by models?
Generated by models?
Yeah, any synthetic data.
Oh, I see. We'll talk about that a little bit later. So the question is, what about model generated, like synthetic data? Are you allowed to use it? The short answer is probably yes. Yeah.
Crawl and stuff like that. I guess because you mentioned earlier that there are websites that have a lot of pirated books on it, right? How do you ensure that those types of websites don't show up in your crawl of the internet?
Yeah. So the question is, there's a lot of websites with pirated books. So if you're just doing a web crawl, you can't look at all the websites. So how do you make sure that everything is kosher? And that's part of the difficulty is you can't. And so there's most likely in Common Crawl, there are copyrighted books and content that you are not supposed to train on, and you can appeal to fair use. Remember, everything is copyright. Books are not remarkably different from your website, for example. Both are copyrighted. Probably a book author has more if they want to go into court, they'll probably be able to protect that better because it's published than your website. But still, and I'll talk a little bit about later. If you really want to be careful, you can do something I'll show later. Okay, so what I'm going to do now is to now talk about the various data sets that are actually used in building models, starting all the way back to 2019. So we've talked about the origin of data and source of data, so you have a feeling for just the general data landscape. And so let's start with BERT. Okay, so BERT was from 2018, and they trained, back in the day, they just trained on Wikipedia and books. So what is this books? So there's this website called Smashwords. It was created that allowed anyone to just put an ebook up to publish. And they had about 500,000 books in 2024. So in 2015, there was this paper who just scraped Smashwords, took the books that were free and just made a corpus. This was back in the innocent days when no one was paying attention to any of this. So this book's corpus was around for many years in the academic academic community. Since then, it has been taken down because it violated the terms of service. Okay, just because it was free and you can get it doesn't mean it was legally allowed. So one thing to note about BERT is that the sequences were documents rather than sentences. All the language modeling research before that was focused on sentences. Okay, so in 2019, GPT-2 came around, and so what did they do? So they wanted to get high-quality web content. And at that time, people knew about Common Crawl, but somehow the Common Crawl data was too messy. So what they did was came up with this clever idea where you can take, you look at pages that are outgoing links from Reddit posts with greater than 3 karma. So good posts must link to good websites. So you grab those pages and you get 40 gigabytes of text, 8 million pages. They never released this data, but there was an open replication of web text, which people use quite a bit. Okay, so that's a GPT-2. So as you're going through this, I guess think about both. There's many methods of filtering and collecting data, and it's interesting to look at these design choices. And okay, so CCNet was developed by at that time Facebook. So the goal was to create large, high-quality data sets for pre-training, and they were especially interested in low-resource languages. So they didn't want some very manual process that only worked for English. So they did a bunch of things. They did duplication and language identification to train a classifier to detect a language and keep only the language that you're looking for. And for quality filtering, the idea that they had was they wanted to keep documents that look like Wikipedia. So Wikipedia at the time was deemed good high-quality content, and they used a language model that was trained on Wikipedia, and you score probability of a new document under that language model to gauge how Wikipedia-like it was. So rather than outgoing links to Reddit, they use a language model on Wikipedia. And they show that because you can get much more data, you can actually outperform training on Wikipedia. And this was a tool that will later appear in some other papers. So here is another work. This is from Google in 2019. So this is called C4. So this paper is actually more famous for the T5 model, which pushes the idea that you should just treat all the NLP tasks in a world as text-to-text. But actually a big contribution of this paper, which is a very long report, was the C4 data set. And the observation, which was very clear at that time, which is that Common Crawl is mostly not useful for natural language, right? There was sort of this idea that you had these small data sets and they were high quality, and then all you had Common Crawl, which was a mess. And any attempt to train on Common Crawl just led to junk results. So people were thinking, like, how do I get a larger but high quality subset of Common Crawl? So we saw the Reddit idea, we saw the Wikipedia-like language model idea. C4 used a different idea, and this is saying, let's just define a bunch of rules, which turned out to be fairly effective. So basically, they keep lines that end in punctuation and have more than 5 words, remove pages with fewer than 3 sentences, remove pages that contain any bad words, remove things like terms of use, boilerplate. Interestingly, they remove the curly brace, which filters out a lot of code. So they weren't, clearly at that time, they weren't thinking about code models. And they filtered out anything that was not English. Okay, the end result is that you have 156 billion tokens, so 800 gigabytes of text. So this is much larger than the GPT-2 dataset, which was only 40 gigabytes of text. A bit later, there was some analysis done in C4, which showed here's the websites that were represented. So you have a bunch of Wikipedia. Patents was a very common thing. They also released the web text-like document. They also used this idea of links in Reddit posts and from Reddit posts with greater than 3 karma and filtered those pages. So they were able to get, using this method, 17 gigabytes of text using 12 Common Crawl dumps. Remember, web text was 40 gigabytes, which means that Common Crawl is maybe incomplete or doesn't have everything, because if it had everything, you should be able to hit 40 gigabytes. And they showed that at that time you could use this data and improve on a bunch of NLP benchmarks. Okay, so we've seen using rules, things that look like Wikipedia, Reddit links, and now let's talk about GPT-3. So GPT-3, the data set was they used Common Crawl, they did their own processing. There was this web text, which was essentially the GPT-2 data set, but expanded. Notice that there's some overlap. Common Crawl does overlap with this, but this is, some sense, a more targeted distribution. There is this, in the paper, it's described as Books 1 and Books 2, which is internet-based books corpora. So this remains a mystery exactly what it is, and Wikipedia. Okay, so the result was about 500 gigabytes of text, 400 billion tokens. And to do the Common Crawl processing, they trained a quality classifier to distinguish things they deemed to be high quality from the rest. And they did some fuzzy deduplication because web text and Common Crawl had dupes. Okay, so this paper followed the idea of using a classifier to train to do quality classification. So after GPT-3 came out, this was, I think, a big event, and there were a number of efforts to try to do things in the open. So one of the initial efforts was the Pile, which is a grassroots effort from Eleuther AI, where they had a bunch of people in this Discord just jamming and figuring out high-quality sources, and they came up with this list in the end. And today, this is still pretty interesting diverse. It has the Common Crawl, it has PubMed, This has this thing called Books 3, which we'll talk about. Archive, GitHub, which we talked about. Wikipedia, IRC, another books corpus, philosophy papers, and so on. And so, they included this Enron emails data set. So Enron went bust in 2002, and all the emails were released. And this is one of the few email data sets we have, which is a weird distribution, I think, for email, but that's what you get. So Project Gutenberg was, so let's talk about books a little bit. So Project Gutenberg was started in 1971, and it only includes books that received copyright clearance. So mostly books in the public domain. And there's this packaging of Gutenberg into PG-19, which is Gutenberg's before 2019. And which is, I guess, most of them, because for them to be in public domain, you have to wait 75 years. So Books 3, which is kind of this interesting data set that appeared in the pile. So this is described, actually, as 200K books from a shadow library called Bibliothèque. That concludes all books from your favorite authors. And at that time, again, 2020, no one was paying attention. It just sat, people used it to train models. And since then, it has been taken down. So you cannot use, or should not use Books 3 anymore. We'll come back to Books 3 again. So Stack Exchange, you've probably used quite a bit, although I guess these days maybe less so because of AI. There's a bunch of user-contributed questions and answers, started in 2008. And one thing that's interesting about this data set is that it's a sort of a Q&A format. And this is quite close to kind of a real application. So normally you think about pre-training data as, here's Wikipedia articles, just like raw text, right? But some parts of the web are actually look like, supervised, like what you would want to ask your language model. So, which I think maybe helps the model learn certain types of question answering behaviors. So not everything is like super magically emergent. It's like, well, this type of data does exist on the web. So there's also, this data has metadata, which is like the number of votes, which are useful for filtering. And again, this data is released in data dumps that allows you to just download without crawling it. Okay, so now in 2021, there was another paper from DeepMind. They trained a model called Gopher, which was never released and actually was sort of subsumed by Chinchilla. But the description of the data, I think, is actually really good. You should read this paper because I think it's very thorough in the way that they describe the data processing. Well, except for the parts where they don't tell you what's in the data. So they created this massive web, and they had C4, which remember was the data set that we looked at before from Google. They train on books, news, GitHub, and Wikipedia. They don't say anything about how they got that. So for the massive web, they kept English, deduped, and their quality filtering was also based on manual rules. And part of the reason for this is that they had more control over that. So I think, as you can see, there is sort of this like division between people who wanted to use rules and people who wanted to use classifiers. So they got a massive, as the name suggests, a massive amount of text. But their model was only trained on like a very small fraction of this data set. Okay, so in 2022, Llama 1 came out, and the data set here, this was actually a very nice paper in that it detailed their data processing. So this is probably one of the last non-open, fully open models that actually talk about their data processing. So they have Common Crawl processed with CCNet, which you know about. The classification, though, was whether the page references was a reference of Wikipedia, not whether it is actually a Wikipedia article. So the idea is that, well, maybe Wikipedia articles are like too stylized. And we know that Wikipedia articles references a bunch of other articles which are presumably good, so let's call those the good websites. They had C4. They did a bunch of processing on GitHub to get permissive licenses. Wikipedia. They trained on, Books 3 and Project Gutenberg. So Books 3 really got them in a lot of trouble because they're just announcing to the world that, hey, I trained on this data set, and if you look back, oh, this came from, where did it come from? It came from the pile. Oh, it came from a shadow library. So, that's why people don't talk about their data anymore. So they looked at archive and actually used the LaTeX to do the processing, Stack Exchange, and they got 1.2 trillion tokens. They didn't actually release this data set, but they had enough of a description in their processing that this was reproduced by Together's Red Pajama V1 data set, which was then used in other sources. So as you can see here, Red Pajama V1 initially also contained Books 3, which has now been kind of stripped out. So various decisions made early on about copyright actually have a fairly big kind of watershed. Okay, so let's talk about refined web. So this is a paper that tried to make a point that web data is all you need, right? So the web, in some sense, is everything. And then we talked about all these specialized sources, like there's GitHub and Archive and Stack Exchange. And they said, well, what happens if we just stick with the web? So they did a good job of doing the transformation from HTML to text. They filtered using the Gopher rules, which is basically keep things that look like English. They explicitly, at that time, still said, avoid ML-based filtering to avoid biases. I don't want to find an overly narrow subset of the web. They did some deduplication, and they had 5 trillion tokens. They released about 600 billion of them. So this Fine Web from Hugging Face was a replication of Refined Web, but improved it. So they took all the Common Crawl dumps at that time, did some filtering, again using manual rules to not inject biases, deduped, did PI removal, and got 15 trillion tokens. So you can see that the size of these data sets is growing quite a bit, so then there is this DOMA data set from AI2, and this is a data set that includes their own processing of Common Crawl, the stack, which we'll talk about before, C4, which you know about, and a bunch of other things. And the Reddit data set was from this project called PushShift. And at that time, you could still get this data, and you can train on it before things got locked down. AI2 has their own crawl of academic papers called Semantic Scholar, so they derive a data set based on that. So let's look at their Common Crawl processing. So they use language identification. So this was model-based, but quality filtering still avoid model-based filtering. And then they remove toxicity using rules and a classifier. And they got 3 trillion tokens out of that. So DCLM, I think, was maybe a point where this idea of model-based quality filtering started to really kind of become the norm here. So data comp, the initial motivation was to define some sort of pipeline so that people can try different data methods in a standard way and show results. But I think the main way that I think people use this is just using their data set that they release to train models and do other things. So they process Common Crawl to produce DCM pool. So this is completely unfiltered. And if you look at this data set, this is massive, 240 trillion tokens. This is probably more than the number of tokens that anyone really trains on. But a lot of this is fairly low quality. So then they have a pipeline where all that gets filtered. If you only keep English, you have some sort of rules to really narrow it down. You do dedupe, and then you do this model-based filtering, and you end up with something that's 1.4%. And this is the data set that we'll see actually works pretty well. So the model-based filtering, and this was kind of strangely good. So to train a classifier, they took Open Hermes, which is essentially instruction data that was generated by GPT-4, and Eli5, which is a subreddit with various questions and answers. So this is, let's see. Like these are the type of questions that are in Eli5. Okay, so anyway, you get the idea. So it's kind of weird, but somehow this works. So the negative examples are anything from refined web, which is, remember, it's just like a very loosely filtered version of the web. It's basically the web, and it got 3.8 trillion tokens. They train a fast classifier. Think about this as a linear classifier, and then they show that this magical quality classifier outperforms a bunch of other things that they tried. So DCLM, this became sort of for a while, at least in the open community, a bit of a gold standard for quality filtering. Let's move on to Nemotron. So Nemotron, this is from NVIDIA. They said that, well, DCLM filters too aggressively. It's removing like most of the data. And remember, they only got, 3.8 trillion tokens, right? So we need more tokens. So what do? We are going to do something more, elaborate. We're going to prompt our existing model to score fine web documents based on educational value. So we're going to prompt the language model and say, is this education or not? Grab a bunch of labels, train a fast text model. So that's one classifier. Another classifier is just using the DCLM classifier. So we're going to use those classifiers. We're also going to use synthetic data. So this is probably one of the, I don't know if it's probably not the first, but one of the main data sets that really lean into synthetic data for pre-training. So they had, for low quality data as deemed by these classifiers, you use a language model to rephrase it to make it more look like Wikipedia. For high quality data, we use a language model to generate various tasks. For example, given a Wikipedia article, I can generate question answers, or I can generate, like, please summarize this document, extract key information from it, and so on. So they resulted in a data set that was 6 trillion tokens. So this is quite substantially larger than DCLM. And just for kind of reference, this is still kind of small by some consideration. So Llama 3 was trained on 15 trillion tokens. Qwen 3 was trained on 36 trillion. Although there is a sort of this it's not clear how big these unique tokens these are, because when you look at token counts in language modeling papers, some of it's like repeated. Like if you do multiple epochs, 2 epochs, that's twice the number of tokens. So you have to be careful when you look at those numbers. And they show that this the data set is better. Their high quality subset beats the previous data sets. Okay, so up until now, we've seen a bunch of different methods for filtering. I think all of these sort of look very kind of similar at some level. You take a web crawl. You either decide I'm going to use rules to filter, or I'm going to use a model. If I'm going to use a model, then I have to decide what looks like good data, and then try to train a classifier and classify all my documents and select. And seems to be a trade-off between, you can take a lot of common crawl. You can get 240 trillion tokens if you want, but that's probably going to be really low quality. Or you can get like 1 trillion tokens, and there's sort of some sweet spot in between. Let me talk about 2 final things. So code and going back to this question of licensing. So the stack is a very nice project that was trying to make a really good coding data set, since it was clear by 2022 that coding was going to be really kind of important. So what they did in the initial version is that they cloned 137 repos. They kept the ones that were permissively licensed, removed example near duplicates, and resulted in 3 terabytes of code. And then in 2024 they had an update, and here they took more the metadata, like the issues, comments, and PRs from GitHub, the repositories from the software heritage, which we talked about. They also scraped documentation from various websites by crawling them. They did a bunch of processing. So in GitHub repos, you have binary files, which you probably don't want to train on. They have malware. You get rid of that. A lot of GitHub, especially these PRs, are bots, so you have to filter that. Dedupe, do PI redaction. There's a lot of pull requests and stuff, and they basically subsample to kind of keep it representative and the data set manageable. They also did this thing, which I thought was kind of nice, which is that there's many programming languages out there. There's a lot of Python, a lot of C, but low resources languages like NIM, which I hadn't even heard of, they're not that common. So what they do is they compile this code and then into a low-level intermediate language, LLVM, which everything like C can compile into this, and they juxtapose the low resource language and the intermediate representation. So then the language model can actually learn the mapping between the shared low-level representation, which has a lot of data on, and the thing that it has less data on. And just for fun, you add in all the other good stuff that you can. So this is sort of Stack V2 is like mostly code and then plus other things that were used to train their coding models. And one thing about pull requests is that their pull requests and all the metadata is not by its nature a linearized sequence. So there has to be some steps to take to linearize it. So one important thing you have to decide is how much context to provide. So for example, event might just be, I change one line of code, right? And that could just be one line, but presumably to learn that you want to provide some context, maybe a few lines around it, maybe the entire file surrounding that diff. And these are some design decisions that you have to make for linearization. And so at the end of the day, the tokens that they train on look something like this, where it's sort of this like XML-like structured data where you have like the PR, and then you have a bunch of diffs, and then for comments, you have basically the event of like a comment was posted, what the review state of that PR was, and so on and so forth. So it's not just learning how to generate code, but also the software development process around code. Okay, so finally I'll talk about the common pile. So recall that almost all the data on the internet is copyrighted. Some of it is permissively licensed, some of it is even in the public domain. And while you can appeal to fair use and say, I'm going to train on it anyway, this is not quite settled, right? So if you're very, very risk averse, then you say, well, let's, if I don't know whether this is okay, that's a no. If you take that attitude, then that's what Common Pile did. So can you train a good model with only permissively licensed data? Or rather, how far can you get? So this was a project that went and scoured the internet for all the different types of data that they could possibly find that was worth training on, that was permissively licensed. It includes Stack v2 and code. It turns out that a lot of government proceedings are actually permissively licensed. Wikis, some things on the web, some news sites are actually permissively licensed. Academic papers, online forums, things that are in the public domain, educational resources, and so on. So in the end, there were 8 terabytes of data, which is actually pretty good for permissively licensed data. Doing this project is actually much harder than maybe it sounds at first glance. It's not just simple as like, oh, you look at the license and it's like, oh, yep, Apache, good, or CC, good. There's some subtleties. First is license laundering. So people are kind of sloppy with licenses. So people might take some copyright work and just put it on, slap a CC BY on it. Anyone can write this on the internet. And it's kind of hard to tell whether this is like a real or not. There's also this common practice where, for example, DOMA is permissively licensed. Remember, DOMA is the AI2 collection, but collection licenses don't extend to the individual works. So the collection is like, first of all, there's a question with collections. I think collections can't be copyrighted, but I guess you can put a license on anything. But the individual works are not necessarily good. So you can't just look at data sets on Hugging Face and many data sets on Hugging Face, you see they have a permissive license, but if you dig deeper, it's actually not permissively licensed at the individual level. And they also made a decision to forego training on any synthetic data, because training language models on unlicensed data is unclear. So probably it's going fine because technically these are like open weight models with MIT license. You can do whatever you can use them however you want, but these language models were presumably also trained on unlicensed data, so it's a little bit of kind of data laundering if you are really kind of honest here. So with this data, they compared with a bunch of other models like the first Llama, MPT, and Quen, and on a bunch of benchmarks, they show that this is not bad. I would say it's not as good as the Quen models for sure, but it's certainly outperforming the very old kind of. This is like from 2023, I guess. So quite old models. So I would say the conclusion here is that you can do reasonably, but I think it's still pretty tough to compete without doing more tokens. But I don't think this is the final word on it, and I think you can probably eke more out of publicly permissive licenses if you try. Okay, so to summarize this lecture here, so maybe hopefully I've giving you some appreciation that data is a very rich topic. It's not that data just falls from the sky, or you just go on Hugging Face and you download a data set. Data has to come from somewhere, and there's also a technical but also social context in which data comes. Because at the top, there's the internet is a bunch of live services, right? Someone has to do the work of producing raw data, whether it be the website that gives you dumps, or someone has to build a crawler, or something. And then someone has to make a decision of how to process it into usable form. Filtering, transformation, deduplication, all of these things have an impact on the quality of your final language model. And notice that filtering is like probably one of the most kind of important things. How do you go from 200 trillion tokens to less than like 3 trillion tokens? I think that obviously is a huge reduction, which I think merits a lot of attention. Data is, in some sense, a key ingredient that differentiates language models. A lot of language models are roughly the same kind of transformer architecture, but data is depending on how you process it, can make a pretty big difference. There's plenty of legal and ethical issues around data, more than I can get into this lecture. And also, this process is very messy. Unlike some of the other parts of this class, where things are maybe more based on kind of first principles, data processing is right now, at least, a lot just based on kind of vibes. You define this classifier, you define this rule, you set some threshold. So there are many opportunities to improve. So as you do your assignment 4, maybe think about whether there's better ways to do this, and this could be maybe a research direction. Okay, so that's it for today. So next time I'll continue talking about data. I'll talk a bit about post-training data and a bit more about filtering.